Welcome to MRL. This is the continuation of the solutions of examples of exercise 2.4 of Polynomials chapter of 9th NCERT textbook 2025-26 textbook being used by the state boards. Now in the first part we have already solved a few examples, and now it is the continuation of that. Now let us begin the example number 2 there. It is given, we have to find out 102 cube, not by product method but by using identity. 102 can be written as 100 plus 2 whole raised to cube, 100 plus 2 whole raised to 3, and we can apply the identity a plus b whole raised to cube. A plus b whole raised to cube is a cube plus 3a square b plus 3ab square plus b cube. Now here a is 100 and b is 2, therefore it is a cube is 100 cube plus 3a square is 100 square into b, that is b is 2, and 3a again 100, b square is 2 square, and b cube is 2 cube. Therefore it is 1 followed by 6 zeros, 6 followed by 4 zeros, and that is 3 into 2 6, that is 6 followed by 4 zeros here, and it is 300 into 4 plus 8. Simplification gives us the answer 1061208. So that is the answer of 102 whole raised to 3. So try to understand that. Now the next example is 998 cube, 998 cube. Now 998 can be written as 1000 minus 2, and again applying the same identity, that is a minus b whole raised to cube, that is a cube plus 3a square b plus 3ab square and plus b cube. Now here a is 1000 and b is minus 2. So putting a cube as 1000 cube plus 3a square b, 3 1000 square minus 2, plus 3, a is 1000 and b is minus 2 square plus minus 2 whole raised to minus 2 cube. Now expansion of 1000 cube will be again 9 zeros here, 1 followed by 9 zeros, minus 3 into minus plus into minus is minus 6, and 1 followed by 6 zeros plus 2 square, that is 4 into 3 is 4 3 is 12, and get 12 followed by 3 zeros, and minus 2 cube is 8, that is minus 8. Now simplification or addition and subtraction of the given of the numbers here gives us the answer 99401 1992, and that is the expansion or of 998 cube using the identity. Now coming to the next example, that is factorization. Now we have to factorize this given polynomial. Now if you look at the polynomial, the first term is a cube term, that it becomes 2a cube. Second term is also a cube term, that is b cube. Now we can apply one of the identities, and the identity which we can use is a cube plus b cube plus 3a square b plus 3ab square is equal to a plus b whole raised to cube. Now let us see whether the next two terms give us the two terms of the identity. Now 3 times 2a square b, because it is 3a square b, so 2a square b, that becomes 6a square b, 2 square is 4, 4 is the 12a square b, it is correct. Then 3ab square, that is 3 into 2ab square, that becomes 3 into 2 is 6, and 6ab square, 100% we can use this identity here. Therefore here a is 2a and b is b, therefore it is 2a plus b whole raised to cube. Therefore the factors are 2a plus b, 2a plus b, and 2a plus b. So these are the three factors of the given polynomial. Now coming to the next example, 8a cube minus b cube minus 12a square b plus 6ab square. Again we have two b cube terms here, so we can use the identity a cube minus b cube minus 3a square b plus 3ab square is equal to a minus b whole raised to cube there, and therefore let us check the next two terms here. First two terms are cubes terms, but the third and the fourth term, this will be minus 3 times 2a raised to 2 into b, so multiply, minus into plus is minus, 2 square is 4, 4 3 is 12, 12ab it is correct. Then 3ab square, 3 into 2ab square, it becomes 6ab square, 100% we can use this identity here. Therefore here a is 2a and b is b, therefore it is 2a minus b whole raised to cube, and therefore the factors are 2a minus b, 2a minus b, and 2a minus b are the factors of the given polynomial. Now the third example is 27 minus 125a cube minus 135a plus 225a square. The first term is a cube term, that is 3 cube. Second term is also a cube term, that is 5a cube, and the third term it is 3a square b, and fourth term is 3ab square. Therefore we can use the identity, that is a minus b whole raised to cube. A is 3 here and b is 5a, and therefore it is 3 minus 5a whole raised to cube, and that is 3 minus 5a, 3 minus 5a, and 3 minus 5a are the three factors of the given polynomial. So please understand that. Coming to the next example, 64a cube minus 27b cube minus 144a square b plus 108ab square. We find the first term and the second term are cube terms. that is 4a raised to 3 minus 3b raised to 3, that is 4a cube minus 3b cube, and the third term and the fourth term are of the form 3a square b and 3ab square, and therefore it is an expansion of 4a minus 3b whole is to cube. Therefore the factors are 4a minus 3b, 4a minus 3b, and 4a minus 3b. So to try to understand that. Now the next example is 27p cube minus 1 by 216 minus 9 by 2p square plus 1 by 4p. Now 27p cube is 3p whole is to cube, and 1 by 216 is minus 1 by 6 cube. That means two terms are cube terms here. Now we have to check whether the next two terms are of the form 3a square b and 3b square. So let us understand this. 3a is 3p, so 3p square, and b is 1 by 6. 3a is 3p and b square is 1 by 6 whole to square. Let us simplify this. 3 square is 9 and 3 ones are 3 to the 6, so 9 by 2 p square, it is correct. And here 3 3s are 9, 6 square is 36, 9 4s are 36, therefore 1 by 4 p is also correct. Therefore it is of the form, expanded form is of the form a cube minus b cube minus 3a square b plus 3ab square. So we can use the identity and write it as a minus b whole is to cube. A is 3p and b is 1 by 6, therefore it is 3p minus 1 by 6 whole is to cube, and therefore the factors are 3p minus 1 by 6, 3p minus 1 by 6, and 3p minus 1 by 6. Now let us go to the next example, example number 9. Now here we have to verify x cube plus y cube is equal to x plus y in the bracket x square minus xy plus y square. So now let us take RHS here. RHS is equal to x plus y into x square minus xy plus y square. It's a binomial into trinomial. Therefore applying the distributive property, let us convert it into monomial into trinomial. Therefore x in the bracket x square minus xy plus y square, and plus y in the bracket x square minus xy plus y square. Now opening the bracket, applying the distributive property again, x into x square is x cube, plus into minus is minus x square y, plus into plus is plus xy square, plus into plus is plus x square y, plus into minus is minus xy square, plus into plus is plus y cube. Now we find here x square y minus x square y and plus minus x square y and plus x square y gets cancelled, plus xy square and minus xy square gets cancelled, and what remains is only x cube and y cube. Therefore x cube plus y cube. Therefore we have got the answer is x cube plus y cube, which is nothing but equal to LHS, and that is how we have verified. This is verified. So please understand this, that x cube plus y cube is equal to x plus y in the bracket x square minus xy plus y square, and that is verified. Okay, please understand that. Now coming to the next example, x cube minus y cube is equal to x minus y in the bracket x square plus xy plus y square. We have to verify it. Again take LHS, x minus y into x square plus xy plus y square. Open this by applying distributive property, monomial into trinomial minus monomial into trinomial. So x into x square plus xy plus y square minus y in the bracket x square plus xy plus y square. X square into x becomes x cube. So we have x square into x is x cube, plus xy into x is x square y, xy square, and minus y plus minus into plus is minus x square y, minus into plus is minus xy square, minus into plus is minus y cube. Now plus x square y minus x square y cancels, plus xy square and minus xy square gets cancelled. Therefore what is left behind is x cube minus y cube, and that is LHS, and it is verified. Now coming to the next example, factorize. We are given 27y cube plus 125z cube. Now 27y cube is 3y cube and 125z cube is 5z cube. That means it is a cube plus b cube form. And we know that a cube plus b cube is equal to a plus b in the bracket a square minus ab plus b square. Here a is 3y and b is 5z. So putting the values here, 3y plus 5z, 3y plus 5z in the bracket 3y whole is to square minus 3y into 5z plus 5z whole is to square. That becomes 3y plus 5z in the bracket 3 square is 9 y square minus 5z is 15 15yz plus 5z square becomes 25z square, and that is what is the factorization of the given polynomial. Now the next example is 64m cube minus 343n cube. Now 64m cube is 4m cube, 343 is into n cube is 7n cube. That means it is a cube minus b cube form. And we know that a cube minus b cube is a minus b in the bracket a square plus ab plus b square. And here a is 4m and b is 7n. Therefore, the first bracket is 4m minus 7n, and in the bracket we have 4m square plus 4m into 7n plus 7n square. So 4m minus 7n in the bracket 4 square is 16m square, 4 7 to the 28 20mn, and 49n square is the factorization of the given polynomial. Now coming to the next example, that is factorization of 27x cube plus y cube plus z cube minus 9xyz. So let us understand this. There is one cube term here, there is a second cube term here, and there is a third cube term here, and there is 9xyz. It appears that we can use an identity here, and the identity which can be used is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c in the bracket a square plus b square plus c square minus ab minus bc and minus ca. So let us bring this in this form. Now I have 27x cube is 3x cube, and y cube is y cube, and z cube is z cube, and this can be written as minus 3 times a is 3x, b is y, and c is z. So it is a cube plus b cube plus c cube minus 3abc form. So we can apply the RHS here. The RHS is a plus b plus c, that is 3x plus y plus z, and a square plus b square, it will be written here, that is 3x square plus y square plus z square minus 3ab, that is 3x into y minus b, that is bc, y into z minus ca minus z into 3x. Therefore simplifying, 3 square is 9x square, y square plus z square minus 3xy minus yz minus 3zx into 3x plus y plus z, and therefore the answer for this will be 3x plus y plus z in the bracket 9x square plus y square plus z square minus 3xy minus yz minus 3zx using this identity. So that is how we find out the the factorization of the given polynomial. Now coming to the next example, we have to verify that x cube plus y cube plus z cube minus 3xyz is equal to half times x plus y plus z in the bracket x minus y whole to square plus y minus z whole to square plus z minus x whole to square. And for verifying this, I will take the LHS and multiply. Take the RHS here, take RHS and multiply. That is half in the bracket x plus y plus z into x minus y whole to square plus y minus z whole to square plus z minus x whole to square. That means half x plus y plus z as it is. Then this apply a minus b whole to square and expand it. Therefore it is x square plus y square minus 2xy. Y minus z square is y square plus z square minus 2yz, and z minus x square is z square plus x square minus 2zx. Now x square and x square, there are 2x squares, and y square and y square 2y square, z square and z square 2z square, and remaining are minus 2xy minus 2yz and minus 2zx. And what we find here is 2 is common. I can take 2 outside. In the bracket I get x square plus y square plus z square minus xy minus yz minus zx, and 2 and 2 gets cancelled here, and therefore we get x plus y plus z in the bracket x square plus y square plus z square minus xy minus yz minus zx. But we know that there is an identity that x plus y plus z in the bracket x square plus y square plus z square minus xy minus yz minus zx is equal to x cube plus y cube plus z cube minus 3xyz, and using that identity we have got the LHS there. So that is the method, and that is what is the verification. Now coming to the next example, if x plus y plus z is equal to 0, show that x cube plus y cube plus z cube is equal to 3xyz. So we have given a condition here, x plus y plus z is equal to 0. We have to show that x cube plus y cube plus z cube is equal to 3xyz. Now we know an identity that x cube plus y cube plus z cube minus 3xyz is equal to x plus y plus z in the bracket x square plus y square plus z square minus xy minus z yz minus zx. This is the identity which we already know. But we are given that x plus y plus z is equal to 0. That means if I put x plus y plus z is equal to 0, RHS becomes 0, and therefore x cube plus y cube plus z cube minus 3xyz is equal to 0. So taking this 3xyz to the right, we get x cube plus y cube plus z cube is equal to 3xyz, and that is exactly what we had to prove, or what we had to show, and that is how it is done. Okay, understand that. Now coming to the next example, that is 14th example, to find the value of this, the cube terms, sum of the cube terms using identity. One is by direct method. Now let us see how to use identity. And we know the one particular identity, that a cube plus b cube plus c cube is equal to 3abc if a plus b plus c equal to 0. Please understand, if a plus b plus c equal to 0, then a cube plus b cube plus c cube is equal to 3abc. That means if x plus y plus z is equal to 0, then x cube plus y cube plus z cube is equal to 3xyz. So let us take the minus 12 as x, 7 as y, and 5 as z. So when we add, we get 0. That means x plus y plus z is equal to 0. But natural, x cube is minus 12 cube, y cube is 7 cube, and z cube is 5 cube, and that is equal to 3abc. So we have got a cube plus b cube plus c cube is equal to 3abc, and therefore when we multiply, we get minus 1260. That concludes that minus 12 cube plus 7 cube plus 5 cube is equal to minus 1260, and that is how we find out the value of the cubes, the sum of the cubes of three terms by using an identity. So that is the method. Now coming to the next example, again same type of example. Let us add 28 minus 15 and minus 13. We get 0. That means a plus b plus c equal to 0. Therefore a cube plus b cube plus c cube is equal to 3abc, and a here it is 28, b is minus 15, and c is minus 13, and therefore 3abc becomes 84 into 195, and that is 16,380 is the answer of this particular example. And again we have used the identity with the given condition that a cube plus b cube plus c cube is equal to 3abc if a plus b plus c equal to 0. Okay, remember that. Now coming to the 15th example, we have been given area of rectangle as 25a square minus 35a plus 12. Now we have to find out the expressions which give us length and breadth. Now to find the expressions means we have to carry out the factorization of this, find out the two factors. One factor will be the length, the other factor will be the breadth. So therefore area is given as 25 square minus 35a plus 12. By middle term splitting method we get 25 square minus 20a minus 15a plus 12, or 5a in the bracket 5a minus 4 minus 3 in the bracket 5a minus 4. That means the two factors are 5a minus 4 into 5a minus 3. That means area which is length into breadth. Therefore length is 5a minus 4 and the breadth is 5a minus 3. So these are the expressions of length and breadth, and that is exactly what has been asked when the area is given to us. Now the next example, again area of rectangle is given, that is 35y square plus 30y minus 12, and we have to find the expression for length and breadth. Again area is equal to 35y square plus 13y minus 12. By middle term splitting method we get the factors 5y plus 4 and 7y minus 3. Therefore length can be taken as 5y plus 4 and the breadth can be taken as 7y minus 3. So a simple method, by factorization we get two expressions. One gives the length, one is the length, the other one is the breadth. Now again here in 16th example, we are given the volume of cuboid as 3x square minus 12x. Now we have to find out the expressions for length, breadth and height of the cuboid, because the volume of a cuboid is L into B into H. So volume is equal to 3x square minus 12x. That means L into B into H is equal to, factorizing this we get 3x is common in this, so 3x in the bracket x minus 4. So therefore 3 is one factor, x is the second factor, x minus 4 is the third factor. Therefore if I take length as 3 units and the breadth will be x units and the height will be x minus 4 units. So these are the expressions. Now coming to the next example, we are given the volume of cuboid as 12ky square plus 8ky minus 20k. Now we have to find the expressions for length, breadth and height again. Now we are given volume is equal to 12ky square plus 8ky minus 20k. Now 4k is common in this. So by taking 4k outside, then we get 3y square plus 2y minus 5 in the bracket. Now we can go for middle term splitting method of 3y square plus 2y minus 5, and by middle term splitting method we find out the two factors of the given trinomial is trinomial are 3y plus 5 y minus 1. Therefore the factors are 4k, 3y plus 5 and y minus 1. Therefore length can be taken as 4k, the breadth can be taken as 3y plus 5 and the height can be taken as y minus 1. So these are the three expressions of length, breadth and height. So these are a few examples of exercise 2.4 of the polynomials chapter, and that concludes the exercise 2.4 of the polynomials chapter. Please go through these examples, learn them, understand the basics. Application of the basics and properties of polynomials must be clear, so that it will be easy for you in higher studies. So note down them in a notebook and practice and learn. Okay, thank you.